Alright guys, I thought that I would go through some of the most difficult problems you'll see on the assessment. And these are the ones where you're going to have to go from grams to grams. So grams to moles, then moles to moles, and then moles back to grams. So you're going to be using a lot of the skills that we've done in this class all together in one big problem. So as I've told you multiple times, when you look at a question like this, and this question says, how many grams of O2 will be produced if 1.07 grams of N2 are produced? We're really looking to compare N2 to O2. Alright? So your instinct should be, when you look at a question like this, is that we should first take this 1.07 grams of N2 and we should try to turn it into moles, because moles is going to be the unit that will let us do the most here. So we can take 1.07 grams of N2 and we're going to multiply it by the mole over the molar mass, or the conversion factor. So 1 mole over 28.02 grams, which is the molar mass. Now, you got that 28.02 grams from the periodic table by just taking N, which is 14.01, and adding it together to have N2, 14.01 plus 14.01. And when we do the math here, 1.07 times 1 over 28.02, or 1.07 divided by 28.02, we're going to be able to cancel out the grams, and we're going to be left with 0.038 moles of N2. Now that we have moles, this actually looks like the easier types of problems that we've been solving. So now we can say, okay, 0.038 moles of N2, and we need to convert those moles, remember, from N2 to O2. So we are going to say 0.038 moles of N2 times 1 mole of O2 over 2 moles of N2. And we got that 1 and that 2, this 1 and this 2, simply from the coefficients that exist in our balanced equation. So 1 mole of O2 goes with 2 moles of N2. We go ahead and do this calculation, and this is going to allow us to cancel out our moles of N2, leaving us with moles of O2. So 0.038 divided by 2 gives us 0.019 moles of O2. The remaining step, because we want our final answer to be in grams of O2, is to convert from 0.019 moles of O2 back to grams of O2 using a conversion factor, again with our molar mass, where we have 32.00 grams of O2 in every mole of O2. And again, we'll cancel out our moles of O2, and this will leave us with our final answer, which is 0.61 grams of O2. So by following through these steps, we were able to take 1.07 grams of N2. We were able to convert that 1.07 grams to 0.038 moles of N2. We then took those moles of N2 and converted them using a conversion factor to 0.019 moles of O2. And this middle equation really tells us that for every 0.038 moles of N2 that we receive, we're also going to receive 0.019 moles of O2, which is essentially a 2-to-1 ratio. We then take our 0.019 moles of O2 and we convert it using the molar mass of O2 back to a mass of 0.61 grams of O2. So these would be all of the steps that I would expect to see from you if you're doing this problem telling me how many grams of O2 will be produced if 1.07 grams of N2 are produced. All right, so let's do one more problem. And so we'll look here at a new equation. We'll consider 4NH3 plus 5H2O yields 4NO plus 6H2O. And now we want to figure out how many grams of NO will be produced by 99.5 grams of NH3. And so we can kind of identify what we're looking for here. We're looking at NO and we're looking at NH3. And what we want to say to ourselves is, all right, 99.5 grams of NH3. As usual, we should try to convert this to moles. So we're going to multiply this by 1 mole of NH3 over the molar mass of NH3, which is 17.04 grams of NH3. We'll be able to cancel our grams out. Cancel. And we will get a final answer of 5.84 moles of NH3. You guys know where we go from here. 5.84 moles of NH3 times 4 moles of NO over 4 moles of NH3. We always want to put on the bottom what we're trying to cancel out. And in this case, 4 over 4 is 1. So we're also going to end up with 5.84 moles of NO. But the mass of that NO is going to be different because 5.84 moles of NO times the molar mass of NO, which is 30.01 grams of NO per mole of NO. Cancel, and that's going to leave us with our final answer of 175.23 grams of NO. So again, start with the mass that you're given, convert that to moles, do a mole-mole conversion. In this case, it's easy because 4 moles of this beget 4 moles of that. Once we get our molar conversion done, we now just take our final moles that we have, multiply it by the molar mass, and we end up with our final answer, which is 175.23 grams of NO. So those are 2 problems that will hopefully help you remember how to do this. Remember that these types of problems are going to be the most difficult problems that you should expect to see tomorrow. There will be a challenge problem that will be a little more difficult, but if you've got this down, you should be fine for everything you need to do.